Alright, let's look at the terms and formulas in GPs, okay? Now, just like, okay, let's write down a group of a GP, a sequence to help explain these terms. Let's say 2, 4, 8, 16, 32, 64, so on and so forth. Alright, now we see that in GPs, the first term of a GP is always be represented by the letter A. So anytime in any GP question or calculation, wherever you see A actually represents the first term of that very particular GP. And for example, if we are to make reference to this GP, our first term is 2. So this 2 is the A of this particular geometric progression. Another thing is our common ratio. Our common ratio is represented with R, and we all know what our common ratio is. It is that number that is common to all the terms here, or that number that is used to multiply the preceding terms to get the succeeding terms. Now, another thing is now wherever you see Tn in geometric progression or in sequence, Tn actually means the term occupying the nth position of that very particular sequence. And what do I mean by that? Now 2 is occupying our first position, right? Now 4 is occupying the second position. 4 is our second term. 8 is our third term, so it's occupying the third position. So whenever you say that Tn simply means the term occupying the nth position. So here 2 is the term occupying our first position. So if I have something like, making reference to this very particular GP, if I have something like T1 simply means the term occupying the first position, which is 2. Now, if I have something like T2 simply means the term occupying the second position. And from these are first position, these are second position. So the term occupying our second position is 4. So if I have something like T3, making reference to this simply means the term occupying our third position. And these are first, these are second, these are third. So the term occupying our third position is 8. And so on and so forth. So if I have T4, it simply means the term occupying the fourth position of that particular sequence. If I have something like T5, it actually means the term occupying the fifth position of that very particular sequence. Alright, next is N. So that N is the position of terms in a GP. So wherever you see N in any GP formula, just know that N is actually representing position. Alright? So we have Sn. So whenever it's Sn in GP simply means the sum to the nth term of a GP. So for example, if you have something like S3, what does it actually mean? It actually means you should find the sum of a particular GP to its third term. So it means find the sum of the first, the second, and the third term. If you have something like S4, now this actually means you should find the sum of the GP to the fourth term. So you need to add your first term, your second term, your third term, and your fourth term. If you have something like S10, S10 simply means to find the sum to the 10th term of the GP. So it is the first plus second plus third plus fourth plus fifth plus sixth plus seventh plus eighth plus ninth plus the 10th term, and so on and so forth. So wherever you see Sn in GP, it actually denotes the sum to the nth term of that particular geometric progression. Alright, next is let's look at the formulas. Now we have that the formula used to find the Tn of any particular geometric progression is its first term times its common ratio raised to n minus 1. So if remember, I said that Tn simply means the term occupying a particular position, right? The term occupying the nth position. So we have, if you're asked to find, let's say T2. Now this simply means that you should find the term occupying the second position, right? Now from this is actually telling us that the formula to find the term occupying the second position is our first term times our common ratio. In order for us to get T2, it to be our first term times the common ratio raised to the power of. Now that position minus 1. So to find T2, it is A times R. Now 2 minus 1 is 1. So it is A R. Alright? Now to find T3, the term occupying the third position, from this formula, it tells us that it is our first term, the first term of the GP, times the common ratio raised to the power of that position minus 1. So T3 is equal to AR raised to the power 2. Now if you are able to find the T4, now this is the term occupying the fourth position, from our formula, it is our first term times our common ratio raised to the power 4 minus 1. So T4 is A R raised to the power 3, and so on and so forth. Alright, now we have R. Now remember I said that R represents our common ratio, right? Now this is the formula for finding our common ratio. It tells us that it is the term occupying any particular position all over its preceding term. Now, the term occupying any particular position all over its preceding term. So let's look at this and make reference to this. Now remember, these are first term, these are second term, these are third, fourth, fifth, and sixth. Now, if I want to find the common ratio to this very particular GP, from this, our formula tells us that I'll need to pick the term on any particular position and divide it by the term in its preceding position. So, now this is my first term, this is my second term, this is my third term, this is my fourth, right? Now I can decide to pick any number here. So let's pick the number occupying our fourth position, let's say 16. So after that, from this formula, our common ratio will be equal to the term occupying our fourth position is 16, all over. Now the term occupying its preceding position, which is this n minus 1. So we have 16 all over 8, sorry, and this will give us 2. Alright? Now I can also pick my, let's say my fifth, the term occupying my fifth position, let's say the fifth position. Now, first, second, third, fourth, fifth. So the term occupying our fifth position is 32. So from here, we have that our R is equal to 32. The number occupying our fifth position all over the number occupying its preceding position, and that is 16. So 32 all over 16, and this will give us 2. Alright? So anytime we want to find our common ratio, we just pick the term occupying any particular position and divide it by the term occupying its preceding position. In that way, you'll always get your common ratio. Alright, now let's look at the formula for Sn. If you remember, I said that Sn is the sum to the nth term of any GP. So now, if you look at this, you find out that our Sn has 3 formulas. It is either this, or this, or this. Okay? And what determines the formula you use? It is our common ratio. Now, for our first formula, it tells us that Sn is equal to our first term brackets 1 minus our R raised to the power n all over 1 minus R. If our R is less than 1. So this tells us that if our common ratio is less than 1, now, and you are needed to find the sum to the nth term of that particular GP, this is the formula to use. Now here we have that Sn is equal to A brackets R, our common ratio raised to the power n, minus 1 all over R minus 1 if R is greater than 1. So here, if our common ratio is greater than 1, this is the formula that is used in order to find the sum of a geometric progression. Now here we have that our Sn is equal to AR, with our first term times our common ratio, if R is equal to 1. So if our common ratio is 1, it means that simply the sum to the nth term is equal to the first term times the common ratio. Okay? Now we also have sum to infinity. Remember, Sn is sum to a particular number, to a particular term or to a particular position. Now, but this is sum to infinity. And it tells us that the formula to find the sum to infinity of a GP is A, our first term, A, all over 1 minus our common ratio. Okay? So let's look at 1 or 2 examples under this.